Let me repeat again. I forgot to start the recording. Okay. What is IPsec? IPsec is a set of communication rules or protocols for setting up secure connection over a network. Internet protocol is the common standard that determines how data travels over the internet, right? So here we use internet to transfer all our data, which is not secure these days. So what we do is we use IPsec VPN, which is helping us to safeguard our data with the help of a tunnel, right? Or you can say it also has a mode of transport, right? IPsec adds encryption and authentication to make the protocol more secure. For example, it zips the data and it unzips it at the destination. It also authenticates the source of the data. So it also authenticates from where the data is received, right? Why is IPsec important? The Internet Engineering Task Force developed IPsec in the 1990s to ensure data confidentiality, integrity, and authenticity, right? Does anyone know about CIA triad? Confidentiality, integrity, and authenticity?
Yes, I know it from cybersecurity
Yes, yes,
lectures.
right. Yes. So, what do you mean by confidentiality?
Reality is when information is only viewed by the authorized or
Authorized
sent by
users.
authorized sender.
Yes, yes. Integrity?
Encryption.
Yes, right. What about integrity and authenticity?
Integrity is tell about the data is sent
It ensure
in
that
original version.
data has not been
Not
tampered with.
change anything. And availability is how we are use easy in the data and make some
Yes.
change or just read it.
Yes, right, Chen. Okay.
Integrity ensure data has not been tampered with in the course of traveling.
Okay. So here the importance of confidentiality, integrity, and authenticity is we can say that confidentiality is the authorized person will view the file. Integrity means the file which is sent will not be you can say in between will get changed or it can be get attacked, right? In between some changes will have occurred. So the file sent it should be received as it is to the client, right? On the client side. Yes, right. Authenticity is to prevent from unauthorized access. It should get to the person or you can say designated person, right? For example, users connect to the internet with an IPsec VPN to access company files remotely. The IPsec protocol encrypts sensitive information to prevent unwanted monitoring. The server can also verify that the received data packets are authorized or unauthorized, right? So, what are the uses of IPsec? IPsec can be used to do the following: provide router security when sending data across the public internet, right? So, with the help of router, we communicate between the between the networks, right? So we have to safeguard our routers first. It also helps us in encrypt application data. It also helps in authenticating data quickly if the data originates from a known sender. So it has all the information if the sender is known or unknown, right? Authorized or unauthorized. It also helps us in protecting our network data by setting up encrypted circuits called IPsec tunnels that encrypts all data sent between two endpoints. So with the help of IPsec tunnel, we can safeguard our data between two endpoints, right? Organizations use IPsec to protect against replay attacks, a replay attack or man in the middle attack. is an act of intercepting and altering ongoing transmission by routing data to an intermediary computer. IPsec protocol assigns a sequential number to each data packet and performs checks to detect sign of duplicate packets. Right? You all know about man-in-the-middle attack, right? Here it also have a name as replay attack. So with the help of IPsec VPN, we can also we can also safeguard our organization from man-in-the-middle attack. So let's understand about the encryption used in IPsec VPN, right? So here the most types of IPsec VPN encryption used is AES, Blowfish, Triple DES, Chacha, and DES-CBC, right? So what IPsec uses is asymmetric and symmetric encryption to provide speed and security during data transfer. Right? It is the advantage of IPsec encryption that it also provides security with speed. Right? In asymmetric encryption, the encryption key is made public while the decryption key is private. In symmetric encryption, uses the same public key for encryption and decryption data. Right, guys?
Right.
Yes. So, how does IPsec works? Let's understand that. Computer access data with the help of IPsec protocol through the following steps. Step number 1. The sender computer determines if the data transmission requires IPsec protection by verifying against its security policy. If it does, the computer initiates secure IPsec transmission with the recipient computer. Step 2. Both computers negotiate the requirement to establish a secure communication. This includes mutually agreeing on the encryption authentication and other security association parameters. So first, what happens over here is they form a mutual agreement about the encryption that they both are using, and all the security parameters on the both sides are accepted, right? So to safeguard our tunnel that we have created, the computer sends and receives encrypted data, validating that it came from trusted sources. It performs checks to ensure the underlying content is reliable. Once the transmission is complete or the session is timed out, the computer ends the IPsec communication. Wait a second. Sorry guys for keep you waiting. So let's understand about the protocols. So over here, there are three protocols used, right? Authentication header, encapsulation security payload, and internet key exchange, right? To exchange the keys. Okay. So let's understand about authentication header. Before that, a header is a proceeding section that contains instructional information for routing the data packets to the correct destination. So a header contains a routing data packets. Second thing is payload is a term that describes the actual information contained within a data packet. So under the routing, there is a payload which describes the actual information contained in the data packet. After that, the trailer is additional data appended to the tail of the payload to indicate the end of the data packet. So here, three data packets are used, right? Authentication header. The authentication header protocol adds a header that contains sender authentication data and protects the packet. Here, encapsulation security payload. In the payload, the data which the user have to send is stored in this trailer. So what happens over here is there are three trailers. One is our routing information, second is our payload, and third is our internet key exchange, or you can say the last packet. Okay, the last trailer. So what happens in internet key exchange is it is a protocol that establishes a secure connection between two devices on the internet. Both devices set up security association, which involves negotiating encryption keys and algorithms to transmit and receive subsequent data packets, right? It shares the encryption with both the devices and it establishes a secure connection between the tunnel, right? There are two modes of IPsec modes. One is tunnel and one is transport. The IPsec tunnel mode is suitable for transferring data on public network as it enhances data protection. While as in transport layer, IPsec transport mode encrypts only the data packet payloads and leaves the IP header in its original form. The unencrypted packet header allows router to identify the destination address of each data packet. Therefore, IPsec transport is used in a closed and trusted network. So we can use transport mode in internal network, or you can say between our branches, which is quite near, right? But the most useful mode over here is tunnel, which can be used anywhere in the world to transfer or create IPsec tunnel, right? With the help of connecting it to ISPs. IPsec transport mode encrypts only the data packets payload and leave the IP header in its original form. The unencrypted packet header allows router to identify the destination address of each packet. Therefore, IPsec transport is used in close and trusted network, such as securing a direct connection between two computers. Right? Okay, guys, let's start with the practical. Okay. Guys, sharing the screen. Okay. Okay, guys, let's start. Let's see. We have config over here. As you can see over here, we have it configured. Let's check this. This is also configured. Okay. Let's go with FortiGate firewalls. Let's give them management interface. Config system interface. Edit port 1. Okay. Set IP static. Set mode static. Set IP 192.168.1.101/24. Set allow access HTTP, HTTPS, ping, SSH. Let's see. Okay. And let's configure Fortinet 2. Admin 123. No. Password will be blank. Admin. Setting password 123. Let's get the management port. Config system interface. Added port 1. Set mode static. Set IP 192.168.1.102/24. Set allow access HTTP, HTTPS, ping, SSH. Sure. Okay. So let's take access to a FortiGate firewall. Okay. 101.192.168.1.102. Okay. Admin 123. So let's go to network interface. Let's go to port 1. Edit. Alias will be WAN. Let's go to port 2. Edit. Port 2 will be 10.1.1.1. It will be LAN interface. 10.1.1.1 slash 24. Okay. We will allow ping. Okay. So these are our port 1 WAN port and port 2 is our LAN port. Port 2 LAN port, port 1 WAN port. Okay. Okay, guys. Let's set a static route. Anything, anywhere will go out from port 1, which will be WAN port. Okay. Let's go to FortiGate 2. Let's increase the time so that we'll stay awake. Ideal timeout, I will keep 50 for now. Admin 123 password. Not now. Later. Okay. Over here, let's go to network interfaces. Okay. So port 1 is our WAN port. Let's give it a role WAN. Okay. Let's go to port 2. Edit. Alias will be LAN. IP will be 20.1.1.1/24. Okay. Clear this? Clear until now, guys? Can I move forward?
Yes, please.
Okay, thank you. So let's set up our VPN. Okay, VPN, IPsec tunnels. We can also create from IPsec wizard. Okay, create new IPsec tunnels, which will indirectly take us over here. Okay, so we will give it from FG1 to FG2. Okay, we will select site to site. We will no NAT between the sites. Okay, the remote device will be our FortiGate. We can also take Cisco ASA IP address. Let's give remote IP address, which is 192.168.1.102. Okay, let's keep it as Fortinet. Okay, this will be your password. Next, local interface will be port number 2. IP will be this. Remote subnet will be 20.1.1.0/24. Okay, let's click on next. Let's review our settings. Okay, let's create the tunnel. Okay, done on FortiGate 101. Let's go to 102. Let's go to VPN. From here, we will do IPsec wizard directly. Okay, we will name it FG2 to FG1. NAT configuration will be no. Remote device will be FortiGate. Next, remote IP address will be 92.168.1.101. Okay, pre-shared key will be Fortinet. Okay, now let's select the local subnet. Remote subnet will be 10.1.1.0/24. If we have multiple, we can add over here. Okay, now we don't have extra routes. That's why I'm canceling it. So it's done. Okay, the VPN has been set up. We can show tunnel list from here. Okay, so now the tunnel is inactive. So what we have to do is we have to create policy on objects so that our LAN can go towards WAN, right? Let's go to Fortinet 101, policy and objects, firewall policy. Okay, we will create a new policy naming LAN to WAN. Incoming will be port 2, outgoing will be port 1. Okay, source will be all, destination will be all, service will be all, action will be accept. We will not use NAT. Okay, click on OK. So this is our implicit deny policy, which is basically default policy, right? This is the policy that is created by our VPN tunnel. Okay, and this is the policy that we have created, and these are the policies that tunnel have created, right? As we can see by sequence, LAN to WAN is over here. Let's go to FortiGate 1, FortiGate 2. Okay, create a new policy. Here also we will give LAN to WAN. Incoming port will be 2, outgoing port will be WAN. Okay, port 1. Source will be all, destination will be all. Okay, services will be all. The action will be accept. That will not be used over here. Okay. So we have created the firewall policy now. Let's check with the LAN tunnels if they are up. See over here, they are still inactive. Okay. So what we can do over here is we can go and bring up all phase 2 selectors. It's up from here. Okay, let's check over here as well. See, it's up, right? So let's try pinging from FortiGate 1, router 1 to router 2. Okay. Okay, guys. Let's give it a ping. First, let's ping the gateway. Okay. Ping 10.1.1.1. That is a success. Okay. Now let's ping the WAN side. Okay. 192. Ping 192.168.1.102, which is our another side, right? So it's not pinging over here. Let's try it once again. Okay. Let's see with the policies. By sequence, let's keep it up over here on both the firewalls. Okay. Now let's check. Let's check with the static route. Okay. Here it is perfect. Let's check over here. Here we have to add one static route. Okay. It will be go to port 1, right? Let's check if we are able to ping between FortiGate firewalls first. As you can see, you can connect between firewalls. Okay. Here we will try 10.20.1.1.10. As you can see, we have successfully created our VPN tunnel, right? Here you can see that we have also get incoming data of the packets. You can also see it over here on both the firewalls. Okay, guys. Any questions?
Hi, sir. Can you just quickly, just briefly tell me again about this?
No problem. No problem. From start?
Yeah, yes, please. Thank you.
Okay. Okay, no problem. So what we did over here is we have two routers which are acting as a PC. Okay, you can say computer. Okay, we have two firewalls and we have to create a tunnel between them. Okay, to transfer our data, right? Securely. So what we will do is we will use this subnets over here for LAN, and we are using this for our WAN. Okay, right? On router we
Right.
have given only the IP address of this 10.1.1.10, and on port 2 of firewall we have given 10.1.1.1, and on port 1 of firewall, which is also our management access, we have given 192.168.1.101/24. Okay, and over here 102 on our second firewall. Right? Clear until here?
Yeah.
Okay. Let's go to firewall 1, where what we will do is we will go to network interfaces. We will give our LAN port IP address as 10.1.1.1. Okay. We will allow ping access. Right? Here we have defined our port 1 as WAN. Okay. Towards our ISP. Right? On both the firewalls, we have to create a WAN port and a LAN port. And then what we have to do is we have to give a static route. Anything from internally will be going directly to 192.168.1.101 on this firewall. Okay. Over here, it will be 102, as the whole LAN traffic will be flowing through the tunnel with the help of dot 102, which is our port 1, right? Okay. So here we have given static routes on both the firewalls, right? Then we gone into our VPN. We can go to IPsec VPN tunnels. What we can do is we can create new IPsec tunnel. We can give our name over here, right? If we have to use NAT, we can. If we have a Cisco device in front of us, for example, here the peer-to-peer device is FortiGate, right? But we can also use Cisco device, ASA you can say. Okay. For example, I am giving some name over here, NGN. I will give IP address. So we are on 101. So the destination IP address will be 192.168.1.101, right? It will automatically select the port. We will give the password. Okay.
Remote IP should be 102, right?
We are on 101.
Okay.
102. So, okay. Sorry.
Okay.
It will show duplicate entry now.
Okay.
Okay. I'm going with 101 for now. Here you can add a local interface. Okay. So here we are using port 2 as LAN interface, right? It will automatically take subnets regarding to LAN 2, LAN port 2. Okay. If you want to add more subnets, if you have in your network, you can add more subnets over here, right? And then you can verify the things we have did over here, and then you can click on continue. /24. Okay. Next, you can verify over here phase 1 interface, phase 2 interface, and all that stuff, right?
Okay.
Okay. So what we will do is we will create this on both the FortiGates. Okay. And after that, we will go to policy. We will create a rule. These rules are created by VPN tunnel itself. Okay.
Okay.
This is the policy that we have built, or we can say we have created. So what we did over here is we are giving a policy so that the LAN can access the WAN, right? The LAN can, if we allow LAN to access the internet, then only it can pass its data from one end to another end, right?
Okay.
Yes, that's what we are doing over here. right?
Mm-hmm.
If you don't create policy over here for LAN, then the data will not pass. Here you can see if we create deny, we did OK, and we ping it from here. It's still going. It's because of these things, right? As
Yeah.
here everything is allowed. Okay. Okay, guys.
Yeah.